Hey everyone, we are looking at indefinite integrals today. So first of all, the phrase indefinite integral, you've seen that before. Well, actually no, you saw definite integral. That'll come back in a few days. Actually the next video, I think. I don't remember. Anyway, it's coming back soon. Indefinite integral is just another name for an antiderivative. So we need a little bit of notation. So like say you're asked, if dy equals 23x squared dx, find y. It's like, wouldn't it be really great if there was a shorter way to write all that? And there actually is. We just do this thing. It looks like an S. And it is an S. And it stands for sum. We will talk later about what exactly we're summing. And that's when we come back to those definite integrals again. So that little thing right there means find the antiderivative. So we can do 23x squared dx. And all we have to do on this is say what has that as its derivative. And we can go, and we don't even need to find y technically. We can just do equals. And then we can integrate this. That's the word for it, we're going to integrate. So we just do the antiderivative thing we've been doing. Instead of having like dy equals and then another line with y equals, we can just do this integral sign. And by the way, this thing that is being integrated is called an integrand. Like if you have a radical, the little check marky thing is called a radical, and the thing being radicaled is called a radicand. Same general word. We have an integral and we have an integrand, the thing being integrated. So we know we have a new exponent of 3, and we also know we want to divide by that new exponent, and I don't need to make this prettier than 23/3. And we also have that plus c because we don't know that vertical translation. That's where the word that indefinite is coming from. It's like, I don't really definitely know where to put this cubic function. So let's have a go at some of these. So you're going to definitely want to read the textbook, specifically pages 197 to 202, and you're going to want to pay close attention to the gray boxes and the examples. That's going to be really, really helpful. Because some of the stuff in those gray boxes are some rules. And one thing is like if you have a constant times something, you can move it to the front. Like I could have, before integrating this, I could have rewritten this as 23 times the integral of x squared dx. And then gone, oh, that's going to be 23 times integrate the x squared, 1/3 x cubed plus c. Same difference. Most people don't bother to do this step unless, well, some people do, some people don't. It's a personal preference thing. I don't usually do it unless for some reason it kind of helps me to picture what's going on. Another thing, if you have a couple of things integrated and they're being added, and I forgot parenthesis in here, there's another one there. It's the same as integrating both of those pieces with a plus in between. And that's just like it is for derivatives, isn't it? Like if you have like y equals thing 1 plus thing 2, you just you derive thing 1 and you derive thing 2 and you throw a plus between them. So it's the same idea. Okay, this is going to look a little weird now. So the next thing is you see this notation a lot actually, where you have something like u to the n du, where u is a function. Oh wait, we've used that before. We usually have a u prime though after it when we're talking about like product ruling or something. But then du is clearly like the differential, technically not the derivative, but the differential of the function, that same function. And so if you want to integrate that, you're adding 1 to your exponent, you're dividing by the new exponent, like what we just did. Okay. If you have, like we know the derivative of e to the stuff is e to the stuff, right? And then times derivative of the stuff. So that's the e to the function times derivative of the function when you're considering reversing the chain rule. That's really what integrating is reversing the chain rule. And then the last one, you'll see this in a box also. Actually, it's not written in the box just like this. I wrote it another way, but that's okay. So like if you have b to the u, so something like 3 to the x, b to the u du is 1 over, because if you derive b to the u, you'd get b to the u natural log b. So we're going to divide by natural log b, reversing the chain rule. So these you'll probably want to have jotted down on your assignment just because it's handy to have them nearby. Having the list nearby is your friend. Okay, let's look at some examples. And we will do that in our next video just to keep things a little bit shorter for the individual videos. So we have our vocab, and next video, a whole bunch of examples.